Assalamu alaikum students. Today we will start with the paper of 2025 October November and first variant paper 6-1. Question number 1. Hot concentrated hydrochloric acid reacts with solid manganese oxide to make the chlorine gas. Chlorine gas is toxic and more dense than air. Concentrated hydrochloric acid is corrosive. Figure 1.1 shows the apparatus used to make and collect a sample of the chlorine gas. There is one error in the way the apparatus has been set up in figure 1.1, and here is a picture of the apparatus. Name the item of the apparatus labeled X in figure 1.1. Alright, so here we have to label the apparatus X here. So basically, we already familiar with this picture. It belongs to the conical flask. This is conical flask. So this is conical flask. Identify the substance labeled Y in figure 1.1. So apparatus Y here. We now we need to identify the substance labeled Y. Be careful, they are not asking for the apparatus name, they are asking for the substance which is present in the present inside this apparatus. So for this purpose, if we go back to the question, it said hot concentrated hydrochloric acid was there that reacted with the solid compound manganese oxide. So the compound is inside of the conical flask over here. This white portion indicates a solid substance present, which means this liquid present in the Y, which is labeled Y, would definitely be HCl. So this is HCl. This is HCl. So we'll write here hydrochloric acid. You can write hydrochloric acid, or you can also write HCl, because they are not asking whether it should be the name or it should be the symbol. So this is hydrochloric acid, or you can also write HCl. Then C says, name an item of apparatus that can be used to heat X in figure 1.1. So heating for this conical flask is definitely be given by the Bunsen burner. You can use Bunsen burner to provide heat. And I hope you are familiar with the diagram of the Bunsen burner. It is something like this. There is a metallic portion with a base like this, and there is a flame coming out from here. This is used for the flame. So this is Bunsen burner. Then D says there is one error in the way the apparatus has been set up. Describe a change that needs to be made to the apparatus in figure 1.1 to correct this error. All right, so if we look at this picture again, we find that there was the statement chlorine gas is toxic and more dense than air. If they are saying that if it is more dense than the air, then within the apparatus, we find this delivery tube is pointing upward, which means the chlorine gas is coming out from this delivery tube, and it should be going into the collection apparatus or container. But at the same time, if the chlorine gas is denser than air, then definitely it cannot be collected inside of it. And the mouth is already open. It is open, so chlorine gas will go downward. So we should think of the correction that must be made by which the chlorine gas can be correctly measured and correctly collected. The main thing is to collect the chlorine gas. So we can think that instead of moving upward, it should go downward, which means the diagram should look something like this. The derivative must go downward in this way, and there must be the receiving flask pointing downward. So the correction that can be applied here is that the downward delivery tube must be used here, and the collection tube, this collection tube should be other way around. That means it should be in the it should not be upside down, it should be in the opposite direction, and we can use the upward displacement of the air. This is upward displacement of air. Because in this way, the air inside this tube will be pushed upward and the chlorine gas will be pushed downward. Chlorine gas is moving downward and the air is pushing upward. So this is called upward displacement of air. So this is how we can do it. And one more way by which we can collect the chlorine gas is that instead of using that tube, we can also use a gas syringe. You are familiar with the gas syringe now, with the plunger at the end. So this gas syringe can be used instead of using the tube. It, as you know, it is just it is set at the horizontal position to the delivery tube. So we can write any of these errors over here. You can write use downward delivery tube, use uh, other way around position of collecting tube. You can use gas range. You can use any of these these corrections. I hope it's clear to everyone. Then part E, explain why this experiment should be carried out in a fume cupboard. The purpose of the fume cupboard is to remove the gases. To remove the gases from your workplace or workstation. Basically, your workplace is the lab. So if you're doing your experiment inside the lab, that is your workplace. And why do we need to remove the gases? Because there can be some toxic gases, some unpleasant gases that might harm you. So in this case, we should know that it is said in the experiment, in the statement, chlorine gas is toxic. So it will be problematic for the person doing the experiment. That's why we will use a fume cupboard. So we say chlorine gas is toxic. Then question number 2, a student investigates a reaction between dilute hydrochloric acid and aqueous sodium hydroxide. There are a lot of words of question number 2. I will ask you to read through these words by yourself from your workbook. They are experiment number 1, experiment number 2, 3, 4, 5, and after that there is a diagram. You can find these from the paper 2025, October, November. Now, A says, use the information in the description of experiment 1 to 5 and the Bureau diagrams to complete table 2.1. This is table 2.1. So we are supposed to fill the type table by the relevant information. First of all, it says the volume of the dilute hydrochloric acid that will be used in all these 5 experiments. So how much volume of the dilute hydrochloric acid is used? According to the question, this is a picture of the burette, and inside the burette, they have used the sodium hydroxide. So we are not supposed to tell the volume of sodium hydroxide. We are supposed to tell the volume of the hydrochloric acid used in all the experiments. So we can see they are using the volumetric pipette to measure the hydrochloric acid, and as you know, volumetric pipette has always a fixed volume of according to the calibration. So in this case, they are using the volume of 25 cm cube. So all these experiments are using 25 cm cube of the hydrochloric acid, each one of the experiment. So we will write here the volume of the hydrochloric acid. That will always be 25.0 cm cube because we are using the pipette, so it has a 1 decimal point as well. So keep that 1 decimal point maintained in all the experiments. So 25.0 in all the columns. Then we have the next column, final bureau reading. Now we will use the diagrams here. You have already performed such diagrams before. We need to place the values in the table. Initial bureau reading, this is for experiment 1, initial and final. So initial value for experiment 1 is, if we look at here, this is 0, 1, 2, 3, 4, 5, 5 cm cube, 0.5. This is 0, this is 0.1, then 0.2, and so on. So this value becomes 0.6. This is 0.6, and this one is final bureau reading. So for final bureau reading, if it is 45, this is 46. So right after that comes 46.1. So you will write 0.6 as the initial and 46.1 as the final. This is experiment 1. Final bureau reading is 46.1 and initial value is 0.6. Then for experiment number 2, initial value, this is 1.123, 1.3 over here. And for final, it is 41.123, 41.3. So 1.3 and 41.3. Then the next column, volume of the aqueous sodium hydroxide added to reach the end point, cm cube. Now this shows, or this column asks you to find the volume of the sodium hydroxide used for the endpoint. That means you are supposed to take the difference of the volumes. They have already done for these three experiments, experiment number 3, 4, and 5. So the values are already calculated here. So they have already calculated for only last experiment number 5. The difference of these two readings is 13.0. So you are supposed to find the differences for all the remaining 4 experiments. So 24.1 minus 0.3. This gives you 23.8, and do the same for the other columns. You will get 34.6 for this one, 40.0 for this one, and 45.5 for this. Now we have completed this table. Moving forward, question number the B part. Complete a suitable scale on the y-axis. On the y-axis, plot the result from experiment 1 to 5. So here you are supposed to plot all the values on the graph. So it means you must have the hard form of the graph paper of this past paper. Only then you can give your answer precisely. So I'm going to use the graph on the screen, and hopefully it will get the correct results. Now on the y-axis, I will just put some points on the y-axis first to make it easier for me. On the y-axis, it's the volume of the sodium hydroxide reached to the endpoint. This is you have to use these values, this column on the y-axis. So it starts from 13 and it ends at 45.5. So you need to select kind of a linear scale that should give you values in this range, and it should be more than half of the graph paper. So if I select, let's suppose, if I select this one as 10, 20, 30, 40, and this is 50. So this will be sufficient for me. So I'm gonna apply this scale over here. This is 10, 20, 30, 40, and 50. Now values 13.0 to 3.8. This is 13.0, 23.8. This is 23, and it is somewhere around here, 23.8. And then 34.6 and 40. Thirty-four point six. So it will be somewhere here. This is at 4.6, and then 40 is just on the line, and the next one is 45.5. So this is 45, and this is in the middle of this value. So I've just labeled the y-axis values. Now I will use the values of the x-axis. Now, the values on the x-axis data the mass. How much mass was used in all the uh, experiments. So they have already mentioned the amounts of the mass used in this experiment. For experiment number 5, 1.5 gram is used. So 1.5 gram against this one. So there is 1 point over here against experiment 5, which is 13. So this point. And 1.5 then 1. So there is a difference of 0.5 in each case. 1.5 then 1, 0.5, and then 0.25, and then 0. So we'll do this accordingly. So for experiment number 4, 23.8 and 1. This is 23.8 and this is 1. And then 0.5 with 34.6. This is 0.5 and this is 34.6. And then 0.25 versus 40. This point over here. And at the last 0 gram and with a point on the y-axis because no mass was used in the experiment 1. So it's already there. Now I have plotted all the points. In that question, they ask you to draw a straight line of best fit, which means it's not a curved line. It's basically a straight line. Now I will try my best to have the straight line here. It will move like this. Okay, so this is the best I could do. Now we have to find the sodium hydrocarbonate added in experiment 2 to 5 neutralizes some of the dilute hydrochloric acid in the conical flask. The sodium hydroxide used in the titration neutralizes the remaining dilute hydrochloric acid. Extrapolate the line on your graph in figure 2.3 and deduce the mass of the sodium hydrogen carbonate needed to neutralize all the dilute hydrochloric acid in the conical flask. Show clearly in figure 2.3 how you would out answer. So you can see that the volume, last volume is almost 13 cm cube. We need to extrapolate the line. We need to extrapolate the line and deduce the mass of the sodium hydrogen carbonate needed to neutralize all of the hydrochloric acid. So we need to extrapolate this line on the right side on the right side to touch on the x-axis. This line must be extrapolated to touch on the x-axis, and that will give you the amount of the mass required to neutralize the whole of the hydrochloric acid, because sodium hydrogen carbonate is basically reacting with a hydrochloric acid. So the volume which is still left over is 13 cm cube. It must be this volume of 13 cm cube must be completely neutralized by the sodium hydrogen carbonate. Its formula is NaHCO3. So I'm gonna extrapolate the line. Extrapolation is just the extension of the line along the same direction. I'm doing this roughly because I'm not doing this using the scale. So this is what I think it will do. It is touching around here. Now, what would the uh, mass over here? We need to calculate. We already now the scale is not the scale is of the 0.5 difference. So for every small box will be 0.05. So it will be 2.05, 2.1, 2.15, 2.2, 2.25, 2.3, 2.35, and 2.4. So it is lying in over the range of 2.35 to 2.4 gram. So that's what I'm getting here. I will write the range 2.35 till 2.40 gram. You need to put two decimal places because all the values in the graph have two decimal places. All right, so this is done. Now the D part. Explain why a volumetric pipette is used rather than a measuring cylinder to measure the volume of the dilute hydrochloric acid used in each experiment. We have already performed this question before. You are familiar now that volumetric pipette are always more accurate than the measuring cylinder. Accuracy of the pipette is greater. So that's what you write here. Pipette or volumetric pipette is more accurate than measuring cylinder. Then part two, explain why it is not possible to use a volumetric pipette instead of burette to measure the volume of aqueous sodium hydroxide in each experiment. Now, the difference between the volumetric pipette and the burette, both are accurate apparatuses, but the purpose of using the pipette instead of burette, why is it not possible? Why can we not use it? Because burette can measure the variable values from 0 till 50 cm cube. It can measure any amount of the volume, any level of the volume in between this range. There is a variable method, but for the volumetric pipette, there is always a fixed value. That fixed value could be 25 cm cube, it could be 15 cm cube, 10 cm cube, whatsoever, according to the pipette given. It is mostly 25 and 10 cm cube used in the labs. So we cannot measure any other value between this range. There is always, as you know, there is always the edge line on the pipette. The edge line lies over here. This edge line always gives the volume according to the apparatus size. That may be 25 cm cube or 10 cm cube whatsoever. So you cannot use the pipette for this purpose when there is a need to keep measuring the volume at multiple ranges at multiple variable volumes. So we will write volumetric pipette measures fixed volume. Then E part. The conical flask is placed on the white tile to make the color change of the indicator at the endpoint of the visible. Explain why universal indicator is not a suitable indicator for this titration. Okay, the purpose of using the white tile is to make the color change very easier to be appear to very easier to see, easier to understand, easier to look at. But why cannot we use a universal indicator here? If you go back to the statement of the question, it asks you to use a indicator over here as a thymophthalene indicator. This is not a universal indicator. All the other indicators apart from the universal indicator will give you only 2 to 3 different colors. They can be 2 colors of them, or there could be 3 colors. One color is given in the acidic solution, one color is given in the neutral solution, and the third color is given in the basic solution. So these type of indicators can give exactly one kind of a color in these 3 different situations. But universal indicator, on the other hand, how does it work? If we look at the literature, which we already covered before from my notes, you can remember that this is a picture of the universal indicator. It has a range of the colors, multiple colors for different pH values. You cannot actually tell the actual endpoint from these different colors. It can keep varying. There is no sharp endpoint. As we know, the pH below 7 is the acidic range. So even in the acidic range, there are multiple colors available: yellow, orange, red. And in the basic range, there are also different colors, blue, violet, with different shades. So that's why we cannot use the universal indicator for this reason. So your answer will be this universal indicator keeps on changing the colors. You can also say it has more than 2 to 3 colors. There is a gradual change in the colors, etc. And after that, you will also say, so cannot determine the endpoint, or endpoint is not clear. Then we have the F part, last part of this question. Draw a line on figure 2.3 to show the results you would expect if the investigation was repeated using the aqueous sodium hydroxide with twice the concentration. Now, sodium hydroxide, if used with twice the higher concentration, what it would mean? If you remember the formula, N is equal to C into V. Here, N stands for moles, C stands for concentration, V stands for volume. We can rearrange this equation to calculate C. C will become N over V. It means C, which is concentration, is related with both moles directly and with volume indirectly. Here they are saying if the concentration is twice, which means the concentration has increased 2 times, C has increased. That means either the number of moles has increased or the volume has decreased. So for this experiment, if we have to increase the concentration, we can think that we have decrease the volume of the sodium hydroxide. So here C is equal to N over V. We have decreased the volume of the sodium hydroxide. So if the volume has been decreased for the sodium hydroxide, what it will have effect on the figure 2.3, which was our graph. We have to label that line. We have to show the line to show the effect of the decreased volume. So on the y-axis in figure 2.3, we have the volume of the sodium hydroxide. So if we have decreased the volume, it means that the new line that will be shown over here, it will be below the already plotted line. We cannot tell actually how much, but at the same time, it also asks you to, it also told you that there is a 2 times increase of the concentration. If the concentration is increased 2 times, that means the volume must also be decreased by half. So what would be the half of this range? This is 45. So the half of the 45 is 22, 45.5 divided by 2, it is 22.75, almost 23. So 23 is over here, 21, 22, and 23. This is over here. That means the new line will start from this side, and it will terminate in the same way as we already did for the red line. Now I will try to plot in the similar way by making a very straight line. So this is what I get here. Maybe it will be more, it will be less steeper, a slightly less steeper. So if you try to do the same way, you can get the line, straight line. The range of the line should be, it should be go like this. It should go like this, and it will terminate over here between the range of 2 to 2.2 over here, this range. Your answer will lie somewhere here. So this will be your line F. This is your F line. So this is how you get a new line on the graph. So do this accordingly for the graph. We have performed these 2 questions of this paper. The next 2 questions will be attempted in the next class. If you have any question, please let me know. So students, that was all for today. We will resume the remaining 2 questions in part 2 of this video in the next class. Till then, take care and bye bye everyone.